Hello, hello. Welcome back to the stream. I want to continue where I left off today, working on the planet shader. I still don't have the chat in OBS, so if you have written anything, I don't know. But yeah, I have my Twitch on the phone now, so yes, the chat works from now on. Let me just get ready. Streaming. Custom browser docs. Yeah, okay. I'm gonna skip it again. I'll take a look some time in the future. Okay, so oh, I didn't even write anything about the stream. Okay. So I think I can begin. My main is here. Good. Everything looks good. Oh, later. Visual Studio Code wants to do the update. Okay, so welcome to stream. Here we go. This is the 20th stream. I didn't actually write anything. This is going to be the 20th stream. And continuing with the sky shader, I'm going to make it a little bit better. So on the past stream, what have I done? I've actually, here is the scene. I actually made this sky shader. And if I rotate the light, which you can see here, it actually like reveals the planet. So it works with lights, it works with directional light. And yeah, and it even, it updates the skybox as well, which is reflected on the station itself. Oh, there's a hole here. It looks kind of like some kind of a telescope, but yeah, anyway. Yeah, and I wrote this whole shader, which is not that long, on my previous stream. So you can watch that one if you're interested in how it works. But yeah, now, and I've also added this like sunset sort of. Well, it's not great because you can see the top of the sun. Actually, that is kind of realistic, kind of. But yeah, basically, when the sun goes down, there it is. There's total darkness. But actually we have a problem. And the problem is that when I hide the sun, as you can see, the sun is still shining on my station, which is incorrect, right? It should not do that. It should actually cast a shadow on it. Okay, so yeah, this is like this is what I need to do today, that I want to do now. So I want to make the Earth occludes light, well, sunlight. Let's do that. And the second thing I want to do is I want to try to add some clouds, because right now there are no clouds, and clouds can actually be in a separate layer. They don't have to be in the texture itself. And also I'm going to try to add cloud shadows. So some shadows that are going to kind of project on top of the Earth. So yeah, those are the three things, and then I'm going to go to sleep. So this is something that I definitely want to add to my sky shader, and maybe, yeah, if everything works out, if everything looks good, I might just call it done, like, because I have other stuff to focus in the game. Well, right now, okay, I want to add, oh yeah, there's one more thing I want to do. Speed up, manipulate time from at runtime. Okay, manipulate time at runtime. So yeah, I want to make a little thing that's going to like speed up and slow down my time. And I totally forgot to share the stream on Twitter, actually. Give me just a moment. Yeah, and while I'm doing that, I can actually play the game. You know, I could actually do a little sunrise. So if I start the game, you can see the sunrise live. Oh, building project. Oh, it is actually running and I'm going to run in full screen. Great. Okay, hopefully that doesn't... Okay, there it is. The sun is coming up. Okay, as we can see, the bloom doesn't kick in yet, but it is going to. And there it is, slowly kicking in. And I'm gonna go share the stream. Oh, hello GitHub. Yeah, this is Fork's problem. Oh, yeah, and yeah, the sunrise, this white band doesn't look so good right now, but yeah, I'm gonna do that some other time. So yeah, there you go. There's the sunrise, and you can't really see anything else. Everything else is black. Yeah, you can see the atmosphere slightly over there, but as the sun rises, we're gonna see, you know, much the rest of the planet. Now I have no idea if you're writing something in the chat, but yeah, just give me a moment. Okay, I'm back. So, yeah, there it is. There's the sunrise. And you know, the light actually looks, thing is that because the atmosphere is a little bit pushed away, it's a little bit bigger than the planet. The thing is that the planet doesn't light until over there, right? And this just looks kind of blue, this part, which is weird. It does look a little bit weird. I don't like that too much, but you know, that is what it is for now. Okay, I'm just gonna hide this so it doesn't complain. All right, so let's start adding this time manipulation. So this is just something that I want to add for debugging. So it is going to be very, very nice and very useful to add, so that I can speed up time, look at the sunsets, you know, maybe rotate the Earth as well in game without having to manipulate it in editor every time. Okay, so loading solution, loading document. Come on, Visual Studio, you can do it. You can do it. Yes, line endings. Yes. Okay, so here we go. We have this Earth script, which actually just basically what it does is that every frame I offset. This is the ideal orbital velocity. That this is the angular velocity of Earth, how much it should rotate, basically. This is in radians per second. So yeah, 1,000th of a second, basically. And then what I do is I rotate the planet and I rotate the sun by the same amount. The sun lighting looks different than last stream. Oh yeah, by the way, yes, one thing that I totally forgot to say is that before stream, good for reminding me. Before stream, I found out how to make Bloom look good. Okay, so that is what I did. That's what I did. Yeah, you say it looks different. Yes, it does look different because I actually added some bloom levels. So basically what it used to be is, you see, these are like the default values. So it basically was like this. It looked like this. And it looked awful, and it was like rectangular, and just like I was like, are you kidding me, Godot? This is how your bloom looks like. And yeah, and if you would make it more powerful, it just looked even sillier. It has this rectangle. And then I was like, wait a minute, it has these levels, which I didn't even see. I didn't even spot in the beginning. So it has these levels, and like, why are these levels so arbitrarily set by default? What if I just set all the levels? And then I realized, oh wait, this is actually what makes the bloom look a little better. Because now it has different levels. Okay, and you can even enhance some of the levels, but yeah, you really shouldn't. Yeah, so, well, it still doesn't look amazing. You can still see the blockiness, the blocky sun, but it's a little bit better, you know. It's like the sun should be blinding, and this does look blinding, so that's cool. Another thing is that I completely misunderstood the meaning of, yeah, and it does light these lights as well slightly. I completely misunderstood the meaning of bloom. So this bloom parameter was on all the time. But what bloom actually does is that it actually makes everything shiny. So basically it doesn't, there's no like threshold to what should glow, right? That's basically it. It just like everything automatically glows, right? So yeah, and then I was just messing around and I killed it, and I was like, wait a minute, now everything looks much better because there's no bloom. I mean, this does look a lot more dreamy, but you know, it's not that. It looks like my eyes are like I just woke up and my eyes are like all blurry. Ugh. Yeah, maybe I should use that for the beginning, like when you start the game. When you start the game, and there is you're looking through like the glass, and you're like, oh my god, look, and then gradually I reduce the bloom. Like, ooh, okay, now maybe you need to do an action to like you know, how do you say, squeeze your eyes to like and then it's like, oh, now you don't have anymore. Cool. Yeah. And yeah, one more thing is that the bloom was actually in additive mode, and in additive mode it overblows the planet a bit. So yeah, screen. Oh, actually in yeah, the original one is soft light, which I don't know why. I don't know why did they make it soft light, but yeah, I think the screen looks better. But yeah, let's try soft light with high intensity. Yeah, this is not great. Yeah, this doesn't. Yeah, this, I don't know. It just doesn't look good. Anyway, yeah, I'm gonna do eight. Oh, there's an HDR threshold as well. HDR scale. Okay, luminance cap. Yeah, that should definitely be maximum. Map strength. Okay, yeah, there's a lot of things that I didn't I didn't even try, but what was it? Yeah, screen. Yeah, definitely should be this one. HDR scale. What does it actually do? Ah, okay, that's just the scale, the like a multiplier for HDR. And luminance cap. Yeah, I guess I shouldn't do that for the sun. Map strength. I don't understand that one. Oh, there is a map thing as well. Huh, there is a way to set your own map, but I don't know what that does. The texture, what? The texture should be used for glow map to multiply the resulting glow color. This can be used to create a lens dirt effect. Oh, I see. Are used for modulation, but the alpha channel is ignored. Ah, I see. So this is like the lens dirt effect. Interesting. Interesting. Okay, maybe I can use something like this if in the future I have like how do you call the spacesuit, right? If you're like outside, and then I can add some lens dirt. Cool. Okay. Well, yeah, and yeah. So basically, these are like turned off by default, and I don't know exactly why. So yeah, why does Godot arbitrarily turn off some things and on? I don't know. Anyway, yeah, this looks a lot better now. And yeah, there you go. The sun is now shiny. The sun is now blinding. I still think that the Sonic Ethers bloom is like still the best bloom I've ever seen in my life, for Unity, of course. Yeah, it was like from more 10 years ago, and it still is the best one. Anyway, how's Godot? Hello, Ampuko. Oh, nice to see you. How goes Godot? Well, you know, it's wrestling. It's wrestling with Godot. I don't know. Sometimes it's amazing. Sometimes it's great. Sometimes it sucks. Yeah, the mesh import process is definitely the worst thing in Godot. Yeah, every time I need to import something, I am like, I don't know. Not only import, but the re-import. When you're updating something, nothing updates automatically. Like, the mesh colliders don't update. So you have to go into every mesh that has a mesh collider and reconstruct it. I don't, you know, I don't understand the choice of that. I don't understand why they don't just reference the mesh the graphical mesh, but apparently they just copy data all the time. Anyway, yeah, I hear it's a bit challenging. Hello, Sleepy. I hear it's a bit challenging, especially for tech art stuff, but I'm still eager to give it a shot. I'm actually pleasantly surprised. I was actually pleasantly surprised with the shaders. So it has like the shader language is actually really simple, and it has for skies it has its own like sky type. You just say shader type sky, and then you call sky, and you do everything inside it, and you just set color. So if I just set color to if I just set color to red, like 3 1 0 0, there it is, and you don't even need to save it. And then you get iron lung, basically. Yeah, you don't even have to save it. It just automatically updates as you type, which is, I don't know. This is something that I really like. Yeah, it seems like the shaders are fun to write. And it has a really good autocomplete for shaders. But yeah, for anything like GD script, I hate it. So I'm just using C# for all my scripting, and of course in Visual Studio. Anyway, yes, but I think that the asset import process is definitely the worst thing about Godot, and I hope they improve that. And yeah, I mean, it's not, I don't know, the performance is not great, actually. Like, Unity runs much better for me. Okay, that's cool. Reshadering. Yes. I hear it's a bit challenging, especially the tech art stuff, but I'm still, yeah. Oh, yeah, that's kind of sick. I don't know what. I've heard it's a little weird with multipass double buffering, raiding back previous buffers, but I don't know how accurate it is. It could be, yes, because, well, right now I'm not doing anything with double buffering or multipass shaders, so this is just a single pass. And yeah, the interesting thing is that the shader editor is actually a separate thing from the script editor, because Godot has a built-in script editor, but it's actually like, okay, this is meant for your scripts. This is where you edit your scripts, and this is where you edit your shaders. So it's interesting, this kind of the duality of shader editor and the script editor. And yeah, it is kind of like integrated. Yeah, this is I heard of people complain about it. Yeah, I don't also understand why is the debugger and output inside part of this part of the main window. So basically when you resize, well, in my case I had to remap to shift space, so that makes any sense. Like, I want to see only this video, only this viewport, and then you shift space, and it's like, oh, it actually keeps this. So every time I have to hide it myself. Yeah, I don't know. I don't understand why this is not a separate window. Anyway, yeah, it has a lot of weirdness, and then there's a lot of hidden features that you just have to figure out. And yeah, I'm not actually in love with the node system. I have to say I'm not in love with the node system, because a lot of times it just doesn't make any sense. A lot of times when if you want to have like multiple components on the same object, you make your subnodes and then you put scripts on them, because in Godot you can only attach one script to one object, and the script actually inherits your thing, your whatever the node type is. So it has this like super deep inheritance, which I'm not a big fan of either, and it kind of forces you to work in that way, which is super weird. Like, if you want to have something like in the case of these buttons, right? I'm like raycasting into buttons to be able to interact with them. You have to inherit something, and you have to like choose what to inherit of these things. because otherwise it won't know. And the weird thing is that, so this is basically the inheritance, right? Node 3D inherits from node, collision shape 3D inherits from node 3D, button inherits. So these are not components. These are not components sitting next to each other. These are actually inherited things. And at the top there is a button. And the thing is that if I made the button, well, in this case, the button is actually, it's actually inherits, yeah, it inherits node 3D. Oh yeah, so here is the interesting thing. Because button inherits node 3D, actually that means that this collision shape 3D is now hidden. So you can, yeah, this is actually not the right sequence of inheritance. Button actually should be sitting here. And the thing is that collision shape 3D is now completely inaccessible from scripts. You cannot access it in any way. It does exist in the game, in the editor. It exists, but you can't access it from the script because this button is shadowing the collision shape. Just weird, really weird. And then one of the things is that if you want to have like a child thing, you have to grab it with a string, like a relative path. I mean, you don't have to, but that's kind of the recommended way to do it. Which yeah, I don't like it. Anyway, oh weird, it's not like a separate panel. Yeah, it's not a separate panel. It's part of this window. Even though like you have this like blue line defining that this is the yeah, it's weird. I don't get it. Yeah, and then you know how in Unity, for example, you can resize anything. You can make this into a maximized window. Well, no, in Godot it's only this thing that can be maximized, only the view. I mean, it's not like I would want to maximize anything else, but you know, it's like it's a special case. This thing is a special case, and I don't know why it should be. So yeah, and you can't actually rearrange this. There's no way to rearrange the, yeah, you can't put this anywhere else. Oh yeah, you can actually put it here. Interesting. Okay, so you can put it in the other. Okay, you can actually do that, but you can't put it in here. This is a special case, definitely. Okay, so going back to my thing. Yeah, so I don't know. It's a love-hate. It's a love-hate with the Godot. I would be so much faster in your. Yeah, of course. Look, the biggest problem of Godot. I mean, what I was actually talking about is a little stuff. The biggest problem with Godot is actually that it doesn't play in the editor. You know, it's actually when you play, it plays into. But let me actually open it as windowed. Okay, when you play, it doesn't play in the editor. It actually opens a new window. And the thing is that you can't inspect it. You can't inspect any of the values. Your game doesn't actually communicate with the editor, so you can't see anything happening in the editor, and that is a huge, yeah. Just like being able to see stuff happening in the editor is such a superpower of Unity. Like that's the biggest superpower of Unity. In my opinion. And I mean, not just Unity, but most of other generalist game engines, I mean. But here you can do it. But weirdly, you can actually manipulate you can actually manipulate stuff like this. Like if I turn the sun, it actually is going to turn in the game. It is really weird. So it's like a one-way communication. It only works here, and then it copies the value into, yeah, it is really strange. But the game doesn't actually like react onto anything you do. Yeah, for example, here I moved the player outside, but nothing happened. Nothing happened in game, and I don't know why, right? Because I'm like I changed the position of the player. Well, I guess that's, you know, something else didn't change. It's weird. Yeah, that's basically the biggest problem of all. Definitely. Okay, and then the weird thing is that your anything you played is actually saved now in in the editor. So if you know, in Unity, I feel safe because anything I do in play mode, well, most of the things, but in the scene, anything I do in the scene, it was going to be reverted once I stop it. But here, actually, everything stays. So if I move the sun, it would have stayed like this, right? It is super weird. It's super weird. I don't like any of that. Anyway, let's. You know what? Before I begin, this grab dist, I've been outputting it forever. Let's remove the grab dist. Grab dist. Okay, there we go. No more grab dist, please. Okay. So, what did I say? I said I want to manipulate time at runtime. Okay, let's influence this rotate by with some keys. So in Godot, to have some key input, you need to do an input. Oh yeah, well, you actually don't need to read events if it's not one-time events. In my case, I'm just going to do it here, and I'm going to have some kind of a, just put it input, and you should be able to get input key, go get access. Yeah, it does have access. I never actually tried to use access, by the way, in here. Oh, I have to hide this. I never tried to use access. I know that it has access because where is that? Project settings, input map. Okay, it's here. So how does it work? How do you add? Add new action. Move sun. Add action. Okay. So how do you show built-in actions? Oh, there are built-in actions. UI accept. Cancel. Left. Is there horizontal? Like in Unity? Nope. What does it say? Anything else that's not UI? Is there any non-UI stuff? No. Okay. So if I added this, so how do I manipulate that? How do I define? Aha, you add here. I see. Keyboard keys. Let's go with keyboard keys. Oh, do I have to? Okay, let's do P and O. P. Okay, well, that took forever to find. Oh my god, so many options. So many options. So what is this? Is this a plus? Or a minus? Or how does this work? Listening for input. Okay. What is this? No. How do I define what it does? How do I define if it's positive or not? I guess you don't. Wait, how does this work? No event. Okay, so these are events. These are events, these are not axes. How do you define an axis? Axis. No. Key label. Okay, let's try this. Godot. Input axis. Well, the thing is that I already made my own like get axis. Okay. Negative action, positive action. Oh, you actually define your actions. Okay, you know what? I'm gonna skip this. I'm gonna leave this for like final thing if I need to remap. But right now, I'm actually going to use my own thing, my own addition, which I call utils input something. No. Key x is raw. Yeah, this is how I call it. So basically, I provide a negative key. That's going to be O. And I provided a positive key. That's going to be P. And it outputs me a move, input move, something like this. Okay, so if input move, I'm going to actually plus, let's do like, because it's going to be delta in both ways. Plus input move. Okay, let's see. Yeah, let's see how this moves. If this is going to move well. Okay, and this is going to be update. If this is going to be fast enough. So yeah, advance time. Let's call it input advance time. I should also add like a multiplier for time, so that I can make it go on faster. Okay, so let's try OP. There it is. We can move. We can now move really fast. Yeah, this is actually perfect. Yeah, this is actually perfect speed of moving the sun as well. So there, I can now test. But yeah, I should actually rotate. I should also add some keys for rotating the planet. Yeah, so that I can adjust it and see not just this, but some other places on the planet. I love how it actually updates the sky. That's pretty. Oh, and you know what? We have to remove the sky, the sun. This is the sun, but in the reflection. Yeah, let me actually do that. Remove sun from cube map reflection. Yeah, because Godot actually allows you to have a separate cube map processing. So yeah, I definitely want to remove that one. Yeah, cool. So yeah, as you see how this module is yellow. If I advance time, now it becomes darker. Well, now there's no ambient light, and yeah, yeah, it is like bluish from the sea. This looks like it's kind of like some waves, but actually it's compression artifacts. Yeah, and then if I go further, yeah, there's the reflection from the desert. Yeah, you can see the difference in like desert yellow and blue ocean. And then here you can even see the reflection from the grass, green one. Okay, but yeah, anyway. I can. Oh yeah, there it is. There's a nice green. What is this actually? Where am I? I don't recognize. Ah, this might be Indonesia or something. No, like somewhere far away. Oh. Wait, I thought this was England, but no, this is not England. I don't recognize this island. Oh, are these the Great Lakes? Yeah, these are the Great Lakes. So that's actually Canada. Yeah, it is like this. Yeah, this is the Canadian islands. Is this Newfoundland? No, I don't know. I don't know exactly the names of these islands. Anyway, yeah, this is the Atlantic Ocean then. And here's Europe. Here's Spain, France. You can see Sicily with Italy. Nice. And here's Africa. North Africa, Sahara. Cool. Okay, anyway. Let's move a bit. So we can advance time. Okay, then let's also float input move texture. Let's have key axis raw key. Let's do K. Oh, and L I'm already using for toggling lights. Yeah, let's use U and I. Okay, and then I'm going to actually set oh yeah, let's see if input move texture, because this shouldn't really move, is not 0. And I'm going to first get parameter. Oh, oh no, I am already setting it. Yeah, I am already setting it. That's the that's the rotation. But yeah, I am going to actually add then the rotate by plus input move texture. Yeah. That's basically it. Oh yeah, I don't need this, and I should multiply this by delta as well. There we go. Okay, let's try this. Let's try if I can. Manipulate time. Okay, so I can manipulate time with the sun. Here we go. And I can only, yeah, there it is, on I, U and I can only manipulate the offset of the texture. Good. Okay, so we can see some other parts of the world now. Oh, this is the Pacific Ocean. What is this? New Zealand, I think. Yeah. New Zealand. Anything else? Yeah, this is the entire Pacific. I can actually set it to like maximum sun and then rotate. So yeah, on this one, on this orbit, I can only see, what is this? Oh, that's the America. Is it? Yeah, this is Mexico. And then this is the Pacific. And then we have the New Zealand. That's basically it. Yeah. Yeah, why not? Why not have this orbit? Nice reflection. Cool. Okay, cool. We have added some keys for yeah, maybe. But maybe I can add, let me actually check. What is the what is the environment? Yeah, one more thing that I wanted to do is I actually wanted to put the Earth a bit sideways, like so that it's not exactly centered on there, so that I can see through my yeah, something like this. Okay. perhaps like that, so that it looks a little bit cooler when you look at through your sleeping quarters. So this is how the game, I think, is going to begin. Like, you kind of see it through your sleeping quarters. But yeah, let's do it a little bit more. Okay, let's go with 035, and here put it to 1. That's maybe good. That's maybe good, but I'm gonna... Oh yeah, and this is now going to be a different part of the world, I think. Let's see what I actually what I can actually see. Let's move the sun a bit. So if I offset, I hate that this collapses every time. If I offset, I can now see, what is this? Oh, this is the Central America. I can see the Central America. It's flying through Africa, Madagascar. Oh, I can actually see Antarctica. Yeah, this is not good because the space stations shouldn't fly over Antarctica. They should be much, yeah, much more. Yeah, you can actually see Antarctica from on the edge. Let's see. Okay, this is the America. I actually had a really good inclination over there, but now because I decided to move the planet, I've completely ruined it. So yeah. Yeah, maybe I am going to... Okay. Let's see what I can do. This one also takes me over... No? No, it doesn't. Okay, yes, it does. This one also takes me over Antarctica. You can't avoid going over Antarctica. Can you? Yeah, I need to actually move this one off center to be able to move not through Antarctica. Ah, there's Norway. There's Norway. Always nice to look at those mountains, at the fjords. Okay, here's Arctic. Yeah, I think I need to offset this by half a pi. So something like this. Okay, where do we go now? What is this? Ah, Antarctica again. God damn it. Okay, let's do 0 here now. Okay, hopefully this takes me over the equator now. Okay. Now now I'm only going over arid places. This is just like Africa and South America and Hawaii. Like, can you avoid Antarctica? It's impossible. Patagonia, Indonesia, Asia, India, Africa. That's not bad. That's not bad. I would love to go over Europe though. But yeah, if I approach... Okay, so here we're going over most of Asia. This is Russia. Japan. New Zealand, okay. Oh, and there's Antarctica. It's like, it really is impossible to avoid Antarctica. Can I somehow rotate out of Antarctica? Okay, whatever I do, I come into Antarctica. Yeah, I think that the only way to avoid Antarctica is to actually offset this one. Okay, why am I even dealing with this? I had the perfect inclination and now I'm like wasting time on this. And putting the right inclination. You know what? Let's just move this away so that they can see a little better. So that was one. That was one. I have to remember that. So yeah, let's see what's going on. Am I actually... Is this the real flight? It is. Okay, I think that this actually makes sense. Wait. This is the flight. Yeah. So, what I need to do is I need to offset this by enough so it doesn't fly. Yeah, this is way too high. This is way too high. I should be going... Yeah, oh yeah, there. Finally we have some meaningful... Okay, there it is. We're not flying over Antarctica now. We're flying over Europe. Yeah, let's keep this. Let's keep this. This is nice. Europe, most of Asia. Yeah, I am actually hitting a lot of ground now. Okay, so let's zoom in. Oh yeah, this is actually even too high because this should be Kazakhstan. Kazakhstan high. It doesn't matter. Doesn't matter. This is a special. This is a special space station inclination. Okay, so this is actually reducing. Is this reducing or increasing? This is reducing. Yeah, okay. Okay. So I need to manipulate the X. Yeah, I think this is good. I think this is good. Good. Let's do this. Yeah, and if I want to make it a little smaller, I can do this. Can do that, and there we go. We are now flying over GB, and over there's Netherlands. Nice, not bad. And we're flying over Moscow as well. Cool, over most of Asia. Can we see Japan? There's Japan. No, that's Taiwan. Japan is over there. And then we go over the Pacific Ocean and then onto South America. That's great. Okay, perfect. I like this. I like this inclination. Okay, so yeah, nice view. Anyway, yeah, found a good one. I don't want to actually add more inputs. This is gonna be it. And so let's not waste time on this. Okay, manipulate time at runtime, done. Remove sun from cube map reflection. So yes, the problem right now is that the sun is included in the reflection, as we can see in the reflected window over here. This little sun disk is part of it, but I actually want to only have it not reflect in the glass. I want to only have it reflect. Yeah, because this is going to be sun. This is going to be a sun specular anyway. So I want to actually keep it in the specular and not in this. So how can we do that? Well, in the shader editor, there is a thing that is like if thing. So in our shader, we can do. No, this is not the shader. My shader reference is somewhere here. Yeah, there it is. So in the shader reference, there's a thing where you can say if cube map. That was one of the first things that it teaches you, and it's not here at all. If cube map, where was that? Oh yeah, that is about the sky shaders. Sky shaders. There it is. Sky shaders, there it is. If at cube map pass. So I'm gonna say sun disk. Sun disk should be 0 if not. So where do I actually add the sun disk? Sun disk color is sun disk. Okay, I'm actually adding it here, but I'm not using it anywhere. Okay, so basically this. And right, it still works. Okay, good. So look at this disk. Is it going to change? If at cube map pass like in English, then I'm just going to do this. Okay, so it only now works in the cube map pass. Yeah, it doesn't exist there. So it's actually should be the opposite. It should be if not at cube map pass, and oh wow, this is way dimmer now, the whole thing. So I guess the cube map sun was lighting it up so much. Interesting. Wait, if I include it, wow, this sun disk was actually lighting up my station. I had no idea that it was so powerful, so much more powerful. Okay, well, now it only lights. This actually looks better because the contrast is better. Oh no, somebody is there's spam in the chat. Sorry for bothering you. Yeah, the price is lower than any competitor. Yeah. How do I? Okay. No, thank you. So, yeah, there we go. I didn't know that this actually contributes so much light. That's strange. That is strange, the cube map. Even this small sun disk actually contributed so much light. But yeah, there we have a nicer reflection from the planet now, because it kind of how would you say, it becomes prominent now more than that sun from the sun disk. But of course the light is still here. Okay, so that's solved. We don't have the weird disk reflection anymore. Okay, fix that. Earth occludes sunlight. Yes. So what is the problem right now? The problem is if sun sets. Come on, start up, please. So Oh yeah, much darker now, but yeah, it seems a lot greener now because it becomes prominent. And where is the sun? Why is the sun not shining? It's because it's behind. Oh, it's because it's below. Okay. So yeah, let me actually speed up. Speed up. Okay, there it is. And now the ocean light also becomes prominent. So yeah, wait, if I go back, yeah, there it is. There is the sun. So look at this now. So if the sun sets behind the planet, right? Look at that. We still have this light. The light still gets shadowed. So yes, I want to actually manipulate the light from the sun, and I want to change it so that yeah. So basically, when I get behind the planet, it disappears. And how are we going to do that? Well, again, we have to apply those same formulas that we used in the shader as well. And those are the sphere intersection, right? Because when does the sun set behind the planet? Well, on Earth, when we're on the ground, it's easy. We have the ground, we have a person. The sun sets when the sun simply goes below like y0. Well, if you take that the sun is an infinitesimal point instead of a disk, right? So if it goes below 0, then it's set. This is set sun, this is setting, and this is up. But on a sphere, right, it is actually setting when it is behind a sphere. And when it is behind a sphere, well, when when you have a planet, let's say that this is actually ground. So this is ground, okay, and we have our viewer over here. There it is, a little person. And if the sun is over here, right, let's say that the sun is over here, is it set? Does the sun set? Well, we take a line and we see, well, it actually has a clear line, so it did not set. Okay, what if the sun is over here, right? Well, yeah, we draw a line and we say, well, we don't draw a line, we cast a ray and we say, oh, look, boom, it actually collides. So that's actually going to go not up until here, but until here. And okay, and let's make this dashing line. There it is. So it has hit, it's occluded. So basically what we need to do is we need to find a, yeah, by the way, let me submit these changes. I still haven't submitted the 8K map. What have I done? I've done added rotation, added input rotation helper for sun. Okay, there we go. We're going to do that, and now what I basically need to do is I need to copy my code that I have for intersection. So intersecting a sphere, I'm going to copy it into here. So this is like shader code versus C# code. This is not going to be, now we're going to rename everything to vector 3, vector 3, vector 3, center out T0, T1, let's keep those. And then we're going to have math dot, does it have, no, it should be vector 3 dot. No, it's actually L dot. Aha, you do it like this. L dot dir. And if is less than 0, we're going to return false. What does it say? What's the problem here? Boolean value, the out parameter must be assigned. Oh, before doing anything, we need to assign an out value. So this is going to be t1 is 0. So let's initialize it. Okay, and here again we're going to have L.L. And then we have that, and finally we have the squirt radius minus d2, and that should be it, right? Let's call that intersect sphere. Maybe there was actually maybe there was already code. Sphere. No. I wonder if there is a primitive thing called sphere. No, there isn't. Okay. Anyway, yes. So we're going to intersect, and what are we going to do? We're going to intersect between 0, well, because the origin is the camera. The direction is the direction to the sun, so it's actually sun forward, the forward of the sun. And yeah, is it the backwards or the forwards? I keep forgetting. Is this the forward? Yes, this is the forward. Let me actually check if this is the sun forward. Aha, it is actually minus forward because this is plus z. Yeah, it is complicated, but yeah, some things use plus, some things use minus. Yeah, like camera is minus z forward, but the sun is plus z forward. Okay, so we have that, and then the center of the sphere. Oh yeah, by the way, how do we get the center of the sphere? Well, I'm gonna have to save the sphere center, and I'm gonna get it from the shader parameter. Planet, this is gonna be planet center, right? I think it is called planet center. Let me check. What's the name of the uniform? Planet center, yes it is. Planet center as vector 3, and that's going to be sphere center. Yeah, let's call it let's call it planet center. And then we have the planet center here. And finally we have the radius, which in my case is going to be 1. We have outfloat t0, which we're not actually going to use. So, well, maybe. Let's see. So, yeah, intersect sphere, we intersect the planet, and yeah, this is actually going to intersect the planet and not the atmosphere for now. So yeah, basically I need to find the planet intersection. So we're gonna has intersected Earth. Yeah, let's call it Earth because, you know, I am in Earth anyway. And I'm gonna say, oh yeah, by the way, sun is not the sun. Let's actually do a little bit of, let's actually screw this up. Okay, for now, I know that sun is sun, right? Is there a way to somehow globally get the sun? Well, I would need to provide it with a path. That's the problem. Okay, well, we can take the sun, because sun is actually the parent in my case. It's the root. I'm gonna say get first child of light. This is something that I did. This is a method that I added myself in my utilities. By the way, I do have a ton of utilities to make it work, to make it easier to work with, and more like Unity style, with like transforming points, directions and stuff, instead of dealing with individual matrices. And these utilities are actually online in the in my utils, in my Godot utils. repository. So yeah, if you want to see my utilities, if you're intending to like move from Unity to Godot or something, yeah, just a few things that makes life easier, like using forward, up, and right instead of global transform.basis.z and stuff like that. Anyway, yeah, so I have the first child, right? I get the first child. Yeah, that is going to be my sunlight. So let's call this directional light 3D, and I'm gonna make it sunlight. Okay, and that's going to be the sunlight. So what is this? Oh, okay, let's do a directional light since we're already there. Okay, so sunlight is directional light, and if has intersected Earth, sunlight dot intensity, is there intensity? Light intensity lumens is interesting. Use physical lights is true. Okay, what is actually the intensity if not using it? Used by directional 3D. If true, sets the intensity. Okay, it is equal luxes in a measure. On a clear sunny day, a surface in direct sunlight may be approximately 100 lux, 100,000 lux. Yeah, maybe I should work in realistic values. I don't know yet, but yeah, for now I'm working in arbitrary. So what's the intensity? Color? Well, get correlated color. What's a correlated color? An idealized black body at the given light temperature. Interesting. Nice. That's a very nice feature that I wish existed in Unity. This value is calculated internally based on light temperature. This color is multiplied by the light color before being sent to the rendering server. Yeah, anyway, let's see what's the name of the intensity. Energy. Oh, it's actually energy. It's energy. That's how you call it. Okay, let's go with light energy. The light strength multiplier. This is not a physical unit. For omni lights and spotlights, changing this value will only change the light color's intensity, not the light radius. Light indirect, light volumetric. Okay, let's go with light energy is 0. Or maybe I can just make it disabled. But yeah, let's go with 0 for now. You know what? I'm gonna do it like this. Sunlight, light energy is has intersected Earth, 0, else 1. There we go. Okay, for the beginning, let's do this. And then we're going to like make it nicer. So let's first see if the light is going to be completely disappear. Earth includes sunlight, and I'm gonna do the Earth atmosphere makes sunlight yellowish. Okay, nice. Okay, so let's see. Let's see if the sunlight disappears. Look over there, and the sunlight is going down. We still definitely have... Oh, look at that. It has disappeared. The sunlight has disappeared, but too early. Too early. This is not the correct... This is not correct at all. Yeah, something weird is going on there. So it should have been... It should have disappeared at this point, right? Not at this point. Interesting. Okay, let's see what happens on the other side. Yeah, it seems like it's slightly offset, like the planet. Do I have some kind of weird offset that I completely forgot to remove? Sun scatter. Sun scatter. That's the sun. At cube map. At cube map pass. Okay. Intersect planet. Idea planet center 1. Vector 3 is 0. This is rotating the normals. The rotating normals does not rotate the planet. No, it doesn't. And then we have the atmosphere. Interesting. And this is the same code. Exactly the same code. Intersect sphere. What am I actually passing it? Okay, 0. Direction is minus forward. Okay. Planet center. Planet center is vector 3. What does the bugger say? Many errors. Add shapes to parent. Parent physics, but it's not found. Okay, that's not my issue. Okay, so there's no problems. What is going on here? Radius intersect. Radius is 1. So from 0, from my camera, oh, yes, because I'm taking the sun, not the actual sun, not the sunlight. I'm actually, this should be the sunlight's forward, not the sun. So this is the sun root. Okay, this is my problem. Let's try it again. I have totally overlooked this. Yeah, let's see. So speed up. There it is. It has disappeared. So the moment the light goes behind. Wow, so dark, so dark. It's only the local lights now, like anything that I have here. Wow. It has never been this dark, because I always had some leaking lights inside here. But now, look at that. This looks like a complete void. I should add some stars as well. Yeah, like I'm going outside, but this is okay. Well, I do have the flashlight, so I can turn on the flashlight. Well, it takes forever to turn on. Oh no! Oh no! It's yeah, there it is. I am, oh, this is actually not outside. This is my this is not outside. This is another yeah, this is outside. That was just another module. Okay, so how does the outside look like? Scary. This is the horror game. Look at that. I'm outside now, but it's complete darkness. Complete darkness. I can see the rest of the station here. Okay. It's a little bit scary. Yeah, if I run time, like you can see that it's actually outside. But here, when the sun goes down, nothing else is visible. So yeah, here we can see that. Okay, let's move away from the station intentionally. Yeah, now when the sun goes down, boom, the lights completely turn off, except for those interior lights. Yeah, you can see lights going through windows, which is pretty cool. Yeah, just suddenly it turns off. Well, this is not what happens in real life. In real life, what happens is that you have yeah, as the light is passing through the atmosphere, it actually dims. It starts yellowish and then goes orangish and then disappears. So yeah, first task done. Well, that's actually the third task today on this stream. Earth occludes sunlight. So when the sun goes around the Earth, it stops shining. Perfect. Okay, so done. Let me add that into the fork. And now we're going to do the second part, which is atmosphere makes sun yellowish. Yes. So yeah, how does it actually look like in real life? Let's do Earth. Earth. Oh yeah. Earth occludes sunlight. Now. Okay. Yeah, let me actually find some cool video. Sunset in space. Sunset in space. Sunset time lapse. Sunset, nighttime, and sunrise from the International Space Station. So yeah, there's actually a really nice combo of colors that happens. Because the sun goes through. Yeah, there it is. It's like a sunset. And then, oh, this actually looked surprisingly blue. Maybe they manipulate the colors. And yeah, you can see the stars now. You can see the star. You can see the ozone layer as well, slightly. Not the ozone layer, the Earth glow and the aurora. But most of the time, it's actually like yellowish. Oh, there it is. Well, there was I don't know if that was a effect or not. Ever look into Rayleigh scattering? I did, but I felt like I don't need it for this. Yeah, I think I'm just going to fake it with. I think I'm just gonna fake it with like a gradient. You know, it's nice. Anyway, let's do some kind of spacewalk. Okay, because spacewalk videos take a long time. Yeah, here 8 hours of spacewalk. This is longer than some of my streams. Well, maybe as long as my streams. Okay, so if we look at some, like, because every 1.5 hours, right, they go into nighttime. There it is. Here's the light time. So now we're looking for the transition between nighttime and, yeah. Sometimes they really capture a nice vibe of the transition between. It's actually surprising how fast it happens. Okay, so here is maybe the sunrise. Yeah, it is hard because you don't really see. Yeah, but I should maybe, if I do the next iteration of this shader, I'm going to use Rayleigh scattering. But for now, I'm just going to use a gradient. No, this is actually not nighttime. This is just. I think they're just in shadow of the station. Let's find something where you can see the night. Yeah, usually when it's night, they change to like other feeds, to the feed of this command center. Ah, there it is. Here's the sunset. Okay, so there we have 2 astronauts working, and there you can see that the light is turning yellowish. That means that the sun is, yeah, and then look at that. Suddenly everything is dark. It happens pretty fast. There it is. experiencing orbital sunset, as they say. So yeah, that was actually pretty fast, pretty quick, and yeah. But anyway, yeah, this is also not a very good reference for the color because I think it's trying to white balance all the time. But yeah, if you did not do white balancing, it would look very yellowish and it go into the orange. It says, let's me look for the sunset again. If I can find something. Gorgeous sunrise. Is this real time? Oh, well, there was it actually. You can see that when it is rising, look at the reflection. Look at the actual color that is being cast from, like, as the sun passes through the atmosphere, right? You can see that it's like orange. It's almost red, and then it turns into white as more of it. So yeah. At the very beginning, it is like red and orange. That was my point. That was what I'm trying to show. That's what I was trying to show. Maybe there is a better one. Sunset. Okay, there is an orange one. Now this is a sunset. Ah, there it is. This one goes on for a little longer. Oh, and this one uses interstellar music, so let's not get copyright striked. Okay, so yeah, it goes on for like 5 seconds. Yeah, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's maybe like 10 seconds of the intermediate sunlight, and then everything else is like just super bright, and you have like 10 seconds of in between. Okay, so let's actually do a little gradient here. Is there a gradient type like in Unity? Yeah, there is. There's a texture as well. Given a set of colors, the resource will interpolate them in order. Okay, yeah. So let's do an export of gradient. Hopefully that will work. Sunset gradient. Let's call it like that. Sunset gradient. And yeah, so what's going to be the input of my gradient? Well, it's going to be, we have to do an intersection of the atmosphere as well. Has intersected atmosphere. Okay. Intersect atmosphere. Wait. Intersect sphere. Yeah, I'm gonna do the intersect atmosphere, and then I'm just going to do the same thing, except that the length is going to be slightly bigger. This is gonna be AT0 and ATI, although I'm not using it. Oh yeah, I'm not using these, so they can actually be discarded like this. All of this can be discarded. Can I use discard? Oh yeah, I can actually, you don't have to write float. Has intersected atmosphere. So yeah, if let's try changing the color. Let's see if that works. Light color. Yeah, so I have to check. He has intersected. Okay, let's do a color. Okay, color. sunlight color. Let's do it like that, and that's going to be white. Actually, it has colors dot white. We begin with white, and we're going to make it. Okay, let's not do that. Let's do. Yeah, let's do white. And then if it has intersected atmosphere, I'm going to change it to the gradient, right? So sunset gradient, and then what is it? Evaluate. Yeah, in Unity it's evaluate. Here it's, what is it called? Add point. Get. Is it just get? Get color. Okay, I guess returns the color of the gradient at index point. No, I don't want the index point at I. I want a float. So how do you get that float? Get offset. Returns the offset of the gradient. No. Can you do like get interpolated? Interpolated color space. Interpolation mode. So what's the actual get? Sample. Oh, there it is. I think it's this. Returns the interpolated color offset by offset. Yes. So what is going to be the sample, right? I need to get a sample between 0 and 1. And it is, yeah, basically I need the distance. I need the distance from this ray to the Earth. How can I do that? How can I do that? How can I find the distance? Distance to the center. There should be actually a formula that does that, no? T0 THC. Maybe that's TCA that I get here. This is the point to center. Oh yeah, well, you know how can I can actually calculate it by getting the point. Well, this is a little bit weird, but you know. Wait a minute. TCA. Project the vector to the center onto the ray. To the center. Project the vector to the center. Onto the ray. Wait. Project the center. So you mean like this? Project the vector to the center. So by to the center you mean this, right? You mean this. This is the vector. And if I project it onto my vector, then calculate the difference from the radius. But if I project the center, I get this. Oh, right. That's exactly what I need. Yeah, and I was thinking another thing. Because we can get the position of where I intersected. Yeah. Yeah. I get it. Okay. So yeah, let's find this vector now to the center. But I have a feeling that that's actually this one, THC. It's like theta to the center or something. Or maybe it's the TCA. L.L minus TCA by TCA. If your sphere intersection function returns the distance through the sphere, you can use that to sample the gradient. You know what? Well, I am stupid. Because t0... Okay, well, here's the thing. Here's the thing. I could just use... Because... Yeah, like if you have a ray, right? This is my t0. This is my t0. This is my t1. Well, that means the middle point is actually this. So I mean, I could do that as well. I could just do a, since I have that for free, right? I can just sample it. I don't even need to project. I could do a, okay, let's do the atmosphere, AT0 and AT1. Okay, with the float. And then what I can do is I can find a position, right? Vector 3. Well, atmos point, it's just T1 minus T1. AT1 minus AT... Oh, no, wait. Oh, you know what? Don't we have the position formula as well? But, oh yeah, no, the position is of this one. Right. So, I'm going to do the... Yeah, I can find the average of AT plus... Okay. If I do this, and then I can just... Oh, but I need to normalize. I need to normalize, which means that potentially expensive. I don't really care about how expensive this is because this is only going to run once a frame. But yeah, like I am going to need to normalize my minus. No, wait. It is the ray, which in my case, oh, it is the sunlight forward, right? Dot normalized by this. Okay, that should be the atmosphere point. And then we have the T, which is going to be the distance, atmos point minus planet center. And then, yeah, and then the length of this. I'm pretty sure there is a way to make this easier. Well, I could actually just, yeah. Anyway, it doesn't matter. And then what we can do is we can do planet radius. Okay, well, I know that it's okay. Let's do just a const because planet radius 1. Oh, I keep doing C++ things, and this is going to be atmosphere radius 1.1. Yeah, let's replace that. Okay. And then I'm gonna do this minus planet radius. And I should also normalize this. Is there a inverse lerp? Yes, there is. Let's do an inverse lerp, actually. Inverse lerp between the planet radius. Okay, this is going to be my lerper. Between the planet radius and the atmosphere radius. And the weight is going to be this. It's actually, yeah, atmosphere point, the length of this. Okay, so hopefully this is my normalized T. And now I can sample it. And there we go, sunlight color. And then I'm not using sunlight color. Okay, let's do sunlight color is sunlight Sunlight color. Okay, there we go. I went too far here. Okay. Yeah, maybe I should put this one in parentheses because so that I don't calculate it with the vector. But yeah, what you said about projecting. If I had to project a point, sunlight project. There's no project. Oh, it should be a vector. Okay, it is project on normal. You can also use that T to affect the light energy. Yeah, that's true. I can do that later. So if I was, but projecting also needs normalization, right? Does it have the source on normal by length squared? Okay, so it does use the length squared and a dot. So it's not, it's a little bit cheaper. And if I had projected, yeah. Yeah, maybe I don't, maybe I can just project. Atmos point is. Okay, let's do the sunlight forward as well as a vector 3 sun as a sun deer. Okay, then I can use that here. Okay, I'm gonna sun deer project onto my, wait a minute, not the sun deer. No, I am actually going to take the planet center and project it onto the sun deer. Okay, and that's basically my, right? If I take the center, because this is the viewpoint is at 0 anyway. Yeah, hopefully that's it. Yeah, much easier than normalizing and multiplying this this average point. Okay, let's see if that even works. Okay, let's make a little gradient. Now that we have, oh yeah, I have to run this. It's for it to compile. Well, yeah, but you say that you can use that T to affect the light energy. Well, actually, I'm going to use the gradient, so I don't need the light energy. I can have the intensity in the gradient itself. Okay, so let's see. Where's my Earth? Sunset gradient, new gradient. Here we go. That's gonna be. Is it actually 0? Is the 0? Yeah, the 0 is actually first. Planet radius. Atmosphere radius, yeah. So actually it should be here. Okay, let's just, for testing, let's do cyan. And at the bottom, there's gonna be red. Okay, so cyan, it will blend in between red and cyan. Interpolation, you can actually set, oh, constant and cubic. Well, there's not much of a oh yeah, there is actually a difference. Color space, OCLUB. Ooh, fancy. You can do OCLUB, OKLab, or how do you say? Oh my god. Unity doesn't have this. You can't specify color space. Nice. So yeah, L-Club is better because it preserves luminance a little better. Instead of the sRGB becomes darker in the middle. Let's try that. Let's try O-Club. All right. Let's see if this is going to work. So, when it's above, it should be white. When it's below, it should be black. But when it's in between, let's see. Oh, it has already, what? Okay, something is wrong. Am I again? Sundeer forward. Sunlight forward. Sunlight forward. I'm projecting on the Sundeer, right? Projecting towards the light. Yeah, that's the one. I hope that returns the vector projected onto another vector. Okay, that's the good. And then I have the atmosphere point. Oh, wait. I shouldn't minus. I should just say atmosphere point length because I'm already lerping between the radius and the atmosphere. Yeah. Okay, so it's white. It has become red here. That's bad. Okay, well, obviously it doesn't work again. So I have something something wrong is happening. Let me double check. What's my radius? What's my other radius? Oh. Wait. It's 101. Okay. Atmosphere radius 101. Okay. That's the one. Okay, so let's see if it works now. There it is. Okay, so it becomes that means this is 0. Okay, yeah. Okay, let's see. The sun is going up. The sun is rising. Come on. Faster sun. We might actually want to push it slightly. Okay. So there it is. It starts showing up, but the cyan one never happens. Yeah, this is actually about the 10 seconds that we have in the real one as well. Okay. Yeah, it never moves towards. There's got to be something wrong. Looks dope. Yeah. Well, hello, Pixus. Okay. So what is going on? Why do I never see this color? What am I doing wrong? Okay. Inverse lerp, the resulting value of the inverse, the return value will be between 0 and 1, but it's not, so it's clamped or not? I guess it's clamped. Planet radius. So from planet radius, if it's 1, this is 1, atmosphere point length is like 1.0 something, and then yeah, let's actually output this. Don't you love print debugging? Okay, let's do it like this with the interpolated strings. And we're gonna have t, and length is going to be atmos point length. What am I doing wrong here? What am I doing wrong? Is this actually 0 to 1? I hope so. I hope Godot does that. You can never trust the engine. I hope it is. Aha! System funk. Great, I'm actually outputting what? How is the T 66? Right? This is not how inverse lerp should work. Okay, I think there's something wrong. I think something is wrong with my inverse lerp. Well, looks like this is not the lerp I want. What the hell? This looks like it. Okay, so it's not clamped, obviously. Obviously, it's not clamped. Yeah, I actually outputted the the function name, not the actual length. So maybe this this projection is wrong. Okay, let's try it using the other atmos point. I'm gonna go have some tea. Okay. Let's see the sunset. Go forward in time. Boom. It's happening. Length. Oh. Okay. Yeah. There's absolutely something wrong. How is it? How is t minus 67? What the fuck? Okay, what am I doing wrong here? What am I doing wrong? I'm projecting the center. Right? This is the center. The center. It's definitely, this is 0. This is 0, 0, 0, definitely. Right? So the center is the length. And I just simply project it to the sunlight. Unless it's this way. Could it be negative? What if I say minus? Well, I don't know if, yeah, but yeah, it's still going to project to the correct point, except that the point is going to be, this could be the problem, because the projected point might be on the other side. Let's see. This would be a silly mistake to make. Nope, it's still the same. It's still the same length. What the hell am I doing? How is this possible? Okay, let's not do this. Sample T. Yeah. What's the length of the Atmos point? Okay, it is like 0.3, which is impossible. It should be close to 1 and not 0.3. What if you multiply sun deer by your but that doesn't make any sense. I should literally just project the center onto the direction of the sun. I'm not changing sun deer anywhere. No, I'm not. Atmosphere point. Planet center, that's the same one. Could it be the minus planet center or something like that? But why would it be? Yeah, I mean, it doesn't, it's exactly the same. Sunlight forwards, normalize. Yeah, this could be actually, this can be sun deer. I mean, it's the same thing. It's the same thing. There's no difference. But yeah. There would be no difference. What the hell? Okay, I'm definitely doing something really stupid, right? I just haven't figured it out. I just haven't figured out what's the stupid thing that I'm doing. Yeah, it's always like this. It's always like this. It's always like this with shaders. Okay, so yeah, I need to make it. Now I need to make it slower. Yeah, as we can see, it's again the same problem. T is minus 30 for some reason. It only becomes less than 1 when it's like in the middle of the Earth. So maybe my logic doesn't work. But yeah, I think it's going to be the same anyway. So atmosphere point, no, atmosphere radius minus planet radius. And then I'm going to do, yeah, well, this, I'm just reinventing the inverse lerp. Yeah, I'm just reinventing the inverse lerp. Unless it is broken. Let's see. Weight, yeah, weight minus from divided by 2 minus. It's the same thing. It's the same thing exactly what I was about to do. And then you get the 0 to 1. Yeah, this is it. Just checking, just double checking, in case the Godot people mistakenly did it. So, what's the problem? Huh? What's the problem? This is definitely the one. Sunlight, right? Sunlight is the directional light. And this gives me exactly the same. So I don't think I'm getting, I'm mistaking in the atmosphere point, because this, I get this exact same values. This is weird. This is so weird. This is so weird. I'm not shadowing some T, right? Some other T. I'm not. Am I scaling somewhere something? Sunlight color. Am I casting to int? I don't know. What else could I do? Mistakenly. Sun direction. Yeah, this doesn't change. Okay, it's a const. What the hell? What the hell? Wait a minute. Wait a minute. Why am I doing a length of this point and not minus center? Wait, why did I actually remove this? I forgot. Wait, is there some kind of a logic why am I actually getting the length of this and not the length of this. Okay, to get this length, yeah, I need to, I don't know. Okay, I hope this is the problem. I hope this was the issue. Okay, let me grab the tea. Now. Okay, so did that solve my issue? Yes. No. Wait a minute. Why the fuck is it now 20? Am I ever going to fix this? What the fuck is going on here? Is inverse argument order correct? I mean, this should be the minimum. Yeah, from to, wait. This is the minus, this is the between. Okay, let's do, actually, let's call this factor. No. Yeah, I'm gonna use the t. But let's just call this in t. I don't know. Okay, let me grab some tea. spilled the tea on my feet. Oh, fuck. Yeah, my okay. Fuck, that hurts. The cup. This never happened to me before. Like the cup slided in my fingers. Yeah, it was weird. Anyway, I survived. Maybe I'll have some wounds, but okay. So let's see what's happening. Okay, so the length. How is the length 1.2? Yeah, there's I'm definitely doing something totally wrong. Totally wrong here. Let's try the other one. You need the differential from the projection and the center, and then subtract the radius from the distance, if it makes sense. But I'm drunk. Well, I'm not drunk and I'm spilling tea all over me. So let's see. Does this make any sense? No, it's the... Oh, wait. Wait a minute. The length is different. Oh, there. This one actually works. Here we go. So the projection thing was actually wrong. The projection thing was wrong. This... So why does the projection thing not work? I'm not actually sure. Minus planet center. Project. Oh, is it because of my minus? What about this? Did I accidentally... wait. Is it because of the minus? Yeah, is the planet rotating? Is there a type of drift element? What do you mean by drift element? Yeah, I mean the planet is rotating. I am simply rotating it in shader. Okay, so this one is also correct now. So they're both correct. It's just that I had a wrong... yeah, I flipped the sign around in desperation. That happens a lot. Yeah, so here we go. The sun is rising. Let's check this. The sun is rising. There it is. Our first light is red. And now look at the gradient on the right, right? It's moving towards the right. There, slowly. Slowly, it's blending the color. So this red is now becoming a cyan. And there we're at past half point. And here we go. We're going into cyan. And boom, it's white. There we go. It's completely outside of the atmosphere. There we go. That's literally the 10 seconds that we're gonna have some different... Okay, cool. Finally works. finally works. Let's remove everything else. Let's also discard this and discard this as well, so that I can submit that. I'm gonna say okay, gradient, well, atmosphere now occludes sun and makes it orange. Well, not yet. Now occludes sun. Okay, so that's the only thing. Okay, now let's improve this gradient. Oh no, I don't want that. So the first color is red, and then I'm actually going to go all the way to white. Okay, that's gonna be my final color. And let's see. Is there a difference? Oh yeah, there is actually a difference. Oh club. Even in a simple red to white gradient. Okay, so let's do something like, let's do a little bit of orangish. Something like this. Okay. Something like that. Okay, let's try this. Yeah, it's just a single lerp. I like how this C. I like how this C. I don't know. Okay, let's see. Okay, sunset. Okay, well, we have sunrise. Sunrise. Okay, the sun is rising, and oh yeah, well, it's actually going to be instantly. It's going to be instantly orange, which I don't actually want. I am going to make it black in the beginning. So yeah, there it is. We have a little transition from orange to white. Let's see if there is any sort of at the very end, if there is a jump or something. Because there shouldn't be. No, that's, yeah, there it is. It ends. Okay, so let's actually push this orange later. And I'm gonna add a black here. So we need to still lerp from black to orange, right? But here is the thing. I actually want to push it a little bit before. So instead of having this radius, instead of lerping, inverse lerping from planet radius to atmosphere radius, I'm gonna add a little bit of a margin. So yeah, let's maybe do a margin const float gradient start, something like that. Gradient start. Yeah, let's go with planet radius minus 0.005 perhaps. Okay, so I'm gonna, instead of planet radius, I'm gonna start from gradient start. So now it should actually start getting orangish before it fully lights up. Oh, but actually the problem is that I'm modifying the sunset, right? Yeah, I'm modifying the intensity before this. Let's see. Okay, well, it is actually going to light up immediately. Yeah. Yeah. So what I'm actually going to do is I'm not going to do this. I'm going to do the light energy. Actually, what happens if the color is just black? Let's see. Instead of modifying the light energy. It's a space station in Godot and modeling in Blender. Yes, it is. It's a space station in Godot with modeling in Blender. Exactly. Exactly. Okay. So here we go. We have pre-sunset. Pre-sunrise. Okay. Let's start from here. Okay, it's coming up. It's getting closer. It's getting closer. Aha. Starting to peak. Well, nothing yet. Nothing yet to reflect on. But 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and it starts getting red. There it is. Oh, haha. Nice. There we go. Share something red, as they say. Nice. I like this. Okay, but yeah, the skylight is not. Yeah, I should actually color the halo as well. That's the problem. The halo should also have the same color. Wow, this is looking awesome. Thank you. Thank you. And there it is. And it's over. The transition is over. And now it's completely... The sun has completely risen. And so yeah, it is perfectly white now. Let's go a little bit further in time. Okay, we can see the whole planet now. And I can actually watch the sunset on the other side. So let's do that. Let's watch the sunset. Oh, there it is. So we should be able to see some good lights on the module over here on the top. Let's see. I'm gonna speed up slightly. Okay, it's touching. It's almost touching. When there's a debug thing starting to list, then the gradient has started. Not yet. Not yet. There it is. It has started to lerp. The color is slowly going into orangish. There it is. Nice. Nice. All right. Here we go. And there it goes. It's now completely dim. Yeah. I guess the sunlight should also be. You know what? Let's just push this. I wonder what is this going to look like. Well, yeah. I wonder if I just push the color, if that's going to be any good. Because in real life, and this is the sunset from space in real life. Yeah, there's this yellow halo. Yeah, the problem is that, yeah, I really need to do that in the shader. Let's try modifying the shader. So how do I know when I'm actually setting sun, when the sun is setting? I can do exactly the same thing as I did in my thing. Yeah, this is the intersecting atmosphere. Okay, let's add a little bit of atmosphere. And this is going to be planet. Whoops. This is planet. Okay, so the cool thing about shaders is that you can debug them easily. Unlike the scripts. So if I put sun behind there. Okay, so I need to check if intersecting. You know what? Here's what I'm gonna do. I'm gonna do a sun disk. Yeah, the color is only going to change at the end. Let's do this sun disk. Okay, I'm going to add sun disk on top. All right, but it needs to be occluded by the ground. So yeah, sun disk should be 0 here. Sun disk is 0. And here I'm gonna put sun disk, no, color plus equals sun disk. What about this? Okay, there it is. The question is this adding a top or not? Okay, so what I can do here is that I can change the color of sun disk if it is inside, right? Let's do a vector 3 and red. Yeah, let's go with red. Oh, the sun disk is actually not a color. Okay, sun disk color is vec3 sun disk. And this is going to be vec3. There it is. Now it is red, shining red. You can dot ray sundir to blend sunset color. Yeah. All right, so if it is up in the sky, oh, look at that. Oh my God, looks great. Yeah, this is actually just the thing I need. Oh my God, look at that. Okay, except let's not do red, let's do yellow. Yeah, maybe less green. There we go. Ah, that's perfect. Damn, that's perfect. Okay, I don't think I actually need... Wow. Accidentally beautiful. I don't think I actually need to do the... Okay. But yeah, I should actually be... Yeah. Yeah. This is it. This is the whole thing. Yeah, well, the thing is that I rely on Bloom to do this. Let's try to make the sun disk smaller. Yeah, the way I'd actually make it smaller is just I increase this number. Okay, well, now Bloom doesn't work at all because it's too small. Yeah, doesn't work in the middle. Yeah, no, I think it was actually fine. This one. Let's see how it looks like from the game. Maybe I can add a little bit of redness. Just a little bit. Instead of pure yellow. Yeah. Okay. Let's try this. Sexy as fuck. Yeah. All right. Let's see the sunrise. Oh. Uh-huh. Oh my god. Oh, so blinding. Yeah, the bloom not being exactly, but yeah, I don't know. If you make this bloom smaller, I think the bloom is okay. I think the bloom is okay, or the glow as they call it. There we go. Beautiful. Yeah, and then even if it like lights up completely, it is still a little bit yellow until it gets out completely, the whole disk, until it gets out of the atmosphere. And there it is. Let's see the sunset. Can I actually just see the sunset for somewhere else? Yeah, let's actually look at the sunset from this module, the other module. It is in here, right? Whoop! I don't want to fly out at space. It should be here. This is it, right? No, this is space. Okay. Yeah, because this is unfinished. This just has open access to space. Come on. No, that's space again. Oh, I almost fell off. My god, that was close. Where the hell is my module? I can't see anything. I can't see shit. Is this the module? No, where the fuck is it? Okay, the light is over there. Is this the module? This is the module. There's the inner hatch. Jeez. Jeez. Okay. Okay, the sun is still there. I can barely see it. Okay, the big window. Okay, there it is. Can I actually see the sunset? Oh! No, I can't. It is actually kind of hard to see through this window. Okay, I can barely see it. Can barely see it. And yeah, it doesn't really, you don't really see the rest of the station. Okay, here's the sunset. There's a little bit of Z fighting over there happening, but here. Yeah, also the color, the color is changing on my carpet. There we go. Now we need more windows. Well, that's the challenge. Cool. There we go. Totally red. Totally red. And then darkness. This one especially because there's nothing. I need to turn on the flashlight. Okay, so yeah, that's it. That's when it comes to atmosphere makes sunlight yellowish. Yes, let's do reddish instead. Beautiful. Beautiful. Okay. So let's log this as reddish skylight. Reddish sunlight. There we go. Okay, next up, clouds. So, do I have some texture with clouds? Earth clouds. Oh yeah, we have some only clouds. Earth clouds, Wikipedia Commons. Not bad. Not bad for Wikipedia. Let's try this. Earth clouds. Oh, it's actually transparent. And yeah, it is not as big as the other texture. Okay. Linspace Godot. Importing assets. Okay, let's add another layer. Let's add another sampler. And the sampler is going to be, where is my samplers? Okay, let's split this a little bit. Okay, I'm gonna add a sampler to the clouds texture. And let's also do filter nearest. Okay, so it's gonna be like this. Okay, so I'm gonna read. First, I'm gonna do it in the atmosphere. So this is my atmosphere. Let's read the texture. clouds texture, and I'm gonna sample the same thing. I'm gonna sample what is it? Where is yes. Actually, I need to do a UV mapping. Ground UV. Okay. Whoops. What have I done? Nothing. Ground UV. Yes. Instead of this, I'm gonna do... Yeah. Let's just call this UV for simplicity. That's going to be UV vec3 clouds. Let's just add that. And RGB. Is that going to compile? No. Rotated normal. Let's not rotate the normal yet. Let's just use hit normal. Okay, hit normal. There we go. It works again. And I'm simply going to say clouds. Yeah, I'm gonna simply add clouds. Okay, well, since nothing is set, okay, clouds texture. Let's go to art, earth clouds. It's interesting that in Godot, like, default is white. So, does it even work? Okay, let's actually read only the red. I wonder if... Yeah, maybe I need to render alpha, actually, because that's transparency. But let's turn this into a vector 3. R? No, let's do alpha. Ah, there it is. It is actually alpha. Okay. Nice. Let me actually multiply by 2. Let's see what happens here. Aha, there it is. Except that this should all be not just plus equaled. Wait. Yes. Instead, I should have... Yeah. Well, it should be on Earth. Actually, now when I think about it. It should actually be on Earth. But I can add another sphere that I can intersect with. So how am I going to include this? Okay, let's actually add it for the beginning. Let's do it on Earth. I'm just gonna... Color is ground. Okay. There we go. And I'm gonna say ground by... No, not by, because... By clouds. Yeah, this, it shouldn't be... It should actually add. It should add on top. So yeah, ground by light. Okay, yes. Ground color. Let's call this albedo. Okay, and so this is not going to, this is going to be albedo, and this is going to be multiplied by light, and this is going to be albedo. Well, okay, here. No, let's call this ground. Let's call this ground. And then albedo is going to be ground plus clouds. Okay, and then the final color is going to be albedo by lights. And ground, what's the problem with the ground? Texture, ground, UV. What's the problem here? Expected, what? Expected a semicolon. Where? Where? Oh, it's this. Sorry. Okay, here we go. We've added some clouds. Okay, that looks good. The problem is that the atmosphere is like lighting this up, although it shouldn't. Maybe I need to push. I need to push the normal as well here. Just like I did in this one. Okay, let's do a 0, 2. Okay, there we go. We have a little bit more of land. But yeah. It shouldn't just disappear completely. That's the problem. Okay, so we have the clouds. We have the clouds. But I actually do want, so yeah, if I move the rotation, the clouds don't move. That's good. That sounds plausible. Okay. But here's what I actually want to do. I want to make the clouds on a slightly different sphere. So let's do another intersection. Another intersection. Okay, well maybe this clouds texture is not the best. Because yeah, let's actually make this A1. I have a feeling like I have a cloud texture somewhere. Some good one. Okay, what if I just make it 4 times? Ooh. Not bad. Does it actually, can you notice? Yeah, it does have. Okay. Okay. Yeah. So. Yeah, the problem is that this is rotation of the whole planet, not the clouds shouldn't be static. Oh, this is rotation of, what is this rotation? Ah, this is the rotation of the sun. Okay. I'm just confused for a moment. Yeah. I do definitely want to have the rotated normal here. Ground UV is okay. Let's do ground UV, which is rotated by 4. Okay. So here we go. We're now moving the cloud layer as well. Yeah, we can see this. We can see this stretch. But this actually looks kind of cool. It looks like there's a band of clouds, except that it repeats a few times. Yeah, not bad. Okay. Well, here's what I want to try. The clouds are also not that. The clouds don't look too bright to me, actually. Let's try to multiply. Yeah, what if I multiply it by 2? Aha. Now this looks better. except that they disappear completely in the on the backside of the planet. Yeah, it would be nice to have some cloud normals as well. That would be funky. Maybe I can make that in Material Maker. Some cloud textures. Look at those fluffy clouds. Nice. Okay, anyway. Yeah, I actually wanted to put them on a separate sphere, but let's actually put this clouds, simple clouds on the ground. Let me actually see how that looks like in game. So what I actually want to do now is I want to put clouds on a separate sphere, so that they're kind of like hanging above the ground. Well, it looks a little bit too contrasty now. Yeah, the clouds might be a little bit too bright. That looks still good. That still looks good, nevertheless. Look at those nice fluffy clouds. Fluffy pixelated clouds. That looks cool. I like it. And here's the sunset. Okay. Yeah, that looks pretty cool. Noise texture 2D. Yeah, I was thinking about noise as well. Is there actually a built-in noise? Oh my god. Good that you told me. I didn't know that it exists. What is a placeholder texture? Okay, let's try the noise texture. What does it say? In 3D space, color ramp. Okay, you can define a fast noise light. Interesting. Okay. How do you use this? Color ramp. Okay, let's do the gradient. Well, nothing. I don't see much difference. There's nothing. I don't know why it doesn't show anything. Why I can't actually see it. Simplex cellular. Nice. It has a lot of stuff that you can do. Oh, fractal. Yeah, I don't know why is it not displaying actually. and nothing else works. Yeah, this works. This works. This doesn't work. Let's not multiply by 2. Okay. I don't know what's going on here. Oh, I was like, what is this hole here? But that's actually the space station. What's the texture noise resolution? It's 512, something like that. Yeah. I mean, I don't think it changes anything. Yeah, it seems to be just white for some reason. Oh. I don't know what's going on. I don't know why I can't sample it. Oh! You know why? I just realized from this texture because I'm reading alpha. That's why. That's why, because this cloud's texture has an alpha. There it is. Okay, let's do R. There we go. You know, cloud's texture, and this is the cloud's noise. Haha. Okay, let's do fast noise frequency. Okay. Increase the frequency. Nice. How expensive is this? Oh no, this is generated once, right? Octaves. Oh! Okay. Lacunarity. Let's increase it a bit for a variety. Gain. Oh! Gain is actually... Wait, what? Gain seems like it's actually manipulating more lacunarity than lacunarity does. Okay. Ridged. Ping pong. FBM. Ooh. What is this? Weighted strength. Interesting. I never encountered this before. The main warp. Ooh. Oh, warp. Let's do some warp. Progressive. Okay, let's do less octaves for the warp. Something like this. Looking really good. Okay, let's do this again by 2. Nice. Okay. A little too much. Let's see how this looks like in when offset. Planet rotation. Okay, yeah, it looks a little bit too evenly distributed. Oh, as normal map. It's not really a normal map, but it does look like. Yeah, no, let's normalize. Hmm. Okay. Nice. I have no idea that this thing exists in Godot. Okay, one more cool thing in Godot. But I want to actually improve. Whoops. I want to increase. Where's the noise parameter thing? Yeah, there it is. It's just below. Yeah, I want to reduce frequency and actually increase the octaves. Oh, that doesn't actually change anything. Okay, it only starts changing once above 5. Okay, something like this. Ah, nice. Noise tool is so useful. Nice, nice. Multiply another noise. Yeah. Yeah, but here's the thing. I could multiply another noise, but if I can get away with just using multiple octaves, that would be cool. And then, like, you know, use lacunarity to control it. You can always add more gain. Ah, there it is. So we can actually multiply the whole thing. Something like this. So when I offset the planet, there's gonna be some places with a lot more clouds. Okay. Does it change anything now if I increase the octaves? Yes. Yes, it does. Okay. Weighted. Okay, let's increase the gain again. Oh, and I'm going to clamp it so it never goes over. Yeah, maybe that was too much. Okay, anyway, let me try adding the clouds. This is nice playing with this. I can do it forever. Simplex reduced. Oh, basic grid. Interesting. Basic grid actually looks better than everything else. Maybe that's because of the... it is the domain warp. Something like this. Okay, let's stop let's stop messing with clouds. Okay, clouds as the... Let's do this. Clouds as noise texture. Okay, so I want to try to do one more thing before I go to sleep, because I'm starting to get sleepy. Actually, first, let me rotate the sun so that I can see it in like full glory. Okay. Then I can also rotate the sky a bit. This cold planet. Okay. Yeah, let me actually add clouds that are on top. No, add clouds. I could say that I've added them. Okay, so in my shader editor, let's try to make another planet, because why not? Intersect planet. Yeah, let's do one more intersect. If I wonder how taxing this is going to be in the GPU, but hopefully not much. Okay, intersect. If intersect vector ID planet center, and let's make it something smaller than, of course, the atmosphere, but larger than the planet. So 005, okay, in between for now. If this is it, then we are going to get the clouds. Okay, so I'm going to hit normal. Do I need to have all this normal for each of them? Okay, let's quickly copy this. Let's quickly copy all of it. And the light as well. Well, what is this? Oh, there's a missing bracket. Okay. And then at the end, I'm going to have clouds. Okay, let's do the UE as well. And I'm going to add, just like I did it here, I'm going to add clouds by light. So plus equals. Okay. There, we can see that the clouds are actually floating in the sky, at the edge, at the very edge. And we should actually have double the clouds. Yeah, I did actually double the amount of clouds. There it is. So here's the thing. I want to actually make the clouds below dark, so it's like it's casting shadows. Kind of like that. So albedo is going to be ground by clamp clouds. Let's see what happens here. Oh. This is what happened. This is what happened. Interesting. Clouds. Oh yeah, well this is actually 1. I need to make it into a shadow. So I'm going to like do a 1 minus. Groovy. You got it working. So this is going to be the cloud shadow is vec3 basically 1 minus clouds, but you know what, this should not be a, yeah, let's do float of clouds. And then the cloud's shadow is going to be 1 minus clouds. Or should it just be minus and then a clamp? And turn it into a vec3. And instead of clouds, we're gonna use a cloud's shadow. There we go. But though we have, I don't see any shadows. I don't see any shadows. Let's just do ground without the shadows. Okay, this is how it should look like. 1 minus clouds. That is what I thought about as well. And that should be 0.0. Nothing. Okay. Aha, there it is. Something is happening. Something is happening. Okay, let's make this like 10 times brighter. Good. But yeah, let me actually clamp. All right. But when it comes to the shadow, Is there any difference? No. Yeah, let's output only the clouds. Can I do a return? No. Using return in the sky is incorrect. Yeah, I think that this actually needs to be less gray. Ah, there it is. Yeah, this was it. It was just supposed to be a little bit stronger. Okay, there we have some shadows in the clouds. Nice. It looks so 3D as well. Very nice. Very nice. Okay, but there's actually a little bit of a problem. The problem here. Okay, yeah, let's not have the shadows. Let's output everything. There it is. Now I'm multiplying with the. Okay, cool. Look at that. Okay, so the problem now is that actually you see, it doesn't actually depend on the direction of the light. I'm just simply putting this on top of the earth. Looking good. Yeah. Let's add a little bit of variety to this. It's a little bit too compact right now. If I change the seed. Oh. There was a seam. Look at those wispy clouds. Not bad. Unless they're too evenly wispy. Yeah. It does it does look a bit like the egg soup. You know, when you drop eggs into boiling water and then forms these egg soup clouds. Oh, in 3D space looks even more interesting. Seamless blend. Okay, interesting. Okay, so what was I saying? I was saying that the problem right now is that the clouds are not really shadows, right? Instead, they're just like offset. So the clouds right now, okay, let's go into Excalibur. Okay, so the problem right now is that we have our Earth. Oh, it should be a solid. Okay. We have our clouds. Our clouds are like this. So, right now, what happens is that the shadow, if this is the cloud here, if this is the cloud, their shadows are actually located just below, like here. But that's actually incorrect, right? Their shadows should actually be like raycasts of sunlight. If sunlight is coming from here, right? These cloud shadows should actually project on top of the sphere like this, and then it projects here. This one will have a long cloud, this one will be here, and this one projects over here. So yeah, slight offset for each. So how are you going to do that? Well, we are going to project this position with the direction onto here, onto our planet. That is my plan. Okay, that's the plan at least. Oh, it's already 4 a.m. Damn it. Okay, so let's do this. Cloud shadows projected. Not really. Okay, so yeah, we have an intersected planet. We have a planet, and this is clouds. Clouds. Oh, that's okay. Are you working on the planet shader? Yes. To add reflection to water. Oh shit! I completely forgot about. That's gonna be for the next stream. Add reflection to water. That's a good idea. Okay. And then I'm going to end. This is going to be the end of the planet shader. Okay, too much. Okay, so, well, here's the thing. When it comes to clouds, right, we can actually do them. Let's do them before the planet. So first we do the clouds. Okay. But we're going to remember them. So it's going to be clouds. Oops, vec3. Clouds. Okay, and I'm going to say that this is going to be black by default. Okay. Vector clouds. Okay. And then we're gonna make this, and then we're gonna, at the end of the planet, I'm going to add the clouds here. Oh no, we're not going to add here. We're going to add afterwards. Plus equals clouds. Okay, and I can actually add light directly, no? Maybe. Maybe I can just multiply with light. Like this. Okay, doesn't matter. Light doesn't matter right now. Okay, so how are we going to project the clouds? So I have the position. I have the position of hit point. Yeah, I have a hit point. And hit point. Yeah, cloud hit point. I also did a shader some time ago myself. Nice. Okay, I'm going to, basically from the planet, from the ground of the hit point, I need to check if I'm going to cast a ray towards, I'm going to cast a ray towards the sunlight. Or negative sunlight. Intersect. So hit point towards the sunlight. Light direction. Minus light direction. Then we have what? We have the center. The center is the same, planet center. Okay, and then we have what? We have the radius. The radius is going to be our... Yeah, let's actually make it into a const. Okay, I'm gonna say const float. Clouds radius. Radisu. Radius, okay. Clouds radius. Okay. This is gonna be clouds radius. And what else do we have? And now we have to output the CT0 clouds is gonna be can I actually do nothing like this? It does. No, it doesn't work. Or am I missing something? Intersect. Where is it? Intersect. 1, 2, 3, 4, and then the outs. Okay, what does it say? Unknown identifier in expression, nothing. Okay, I guess I can't have it. CT0. Can I output to both? I wonder if this works. Oh, it does actually work. Okay, and this needs to be 0, 0. Okay, so I'm intersecting. That's actually going to be true. What I need to do, how do I actually, I need to get the point. And I need to sample the cloud layer again. That's the thing. That's the thing. Yeah, there's a lot of sampling. Yeah, actually a lot of things here should be put into functions. I'm gonna clean up the shader tomorrow. So what am I doing here? I'm getting a point for each point on the Earth, right? I'm projecting in the direction of the sun to get a point on the outer sphere. Yeah, the problem is that, what is this T1, T0, right? Is it the T0 if I'm inside? If I'm inside, then T0 is going to be closer, I guess. Okay. Yeah, and what I need to do, so in the same way as I did this, you know what? Let's put this in a function. Let's put this in a function. Okay, something like this. Planet rotation. Okay, so that's, I can just do rotated normal, rotate, hit normal. Okay. Yeah, that's the same thing, right? Yeah, it is. Okay, this is the clouds. Clouds. Okay, let's actually exchange this one as well. Ground UV, rotated normal. All right. So, intersecting, light direction, planet center, cloud radius. Let's actually split this into CT1. This is going to be CT1. Okay, and now I need to do the UV. I need to do the clouds normal. And the cloud's position as well. All right, we have the normal. Now I can convert normal into I can read. Where was that? Yeah, there it is. I can take the UV. Yeah. Close UV. Clouds normal. And finally, I'm gonna read the clouds again. So yeah, instead of this, I'm actually going to read the clouds. Wait. This is the planet. This is the UV. Wait, I'm not actually using the UV. Unknown identifier clouds UV. Okay, and now we have repetition of clouds. All right. Well, this should be it, but it's not working. And why is it not working? Could it be that it is actually the cloud point is actually CT1? Oh! Maybe it is. Look at that. Look at that. We have something. I don't know what this is, but it looks funky. Okay, yeah, it's not actually rotated. Clouds normal. Let's go with rotate. Okay, so that it also rotates. Aha, there we go. Nice. Okay, maybe it is CD0, but it is so close that we can't see. No, there's something wrong. There's something wrong. It's 420. Yeah, I know. I know it is. Don't put salt on my wound. Maybe it is a light direction. And then we get CD1. Nothing happens. Why does nothing happen? Yeah, the UV is wrong. There's something weird happening. I think it's the intersection. The intersection point is just weird. Ah, maybe this should not be the idea. Maybe this should be the normal. Something has happened. Interesting. Okay, what if I exchange it with 1 now? That doesn't do much. Okay, let's try getting the sun. Oh, there we have something. Something looks more familiar. I think this is partially working. Partially. Clouds point. Okay, let's clouds texture. Clouds texture. Okay, let's make it like super dark. Yeah, this doesn't work. No, there is some kind of a scaling thing here going on. CT, let's try CT1. No, that doesn't do anything. That doesn't do shit. Okay. Yeah, I don't know if this is even correct. Hit point, and then you use the light direction to read off. Okay, at some point I think it's working, but I don't think it is. So let's review everything. We go from the hit point, where that's origin of the ray, towards the direction, and then I go from the center of the planet. Wait a minute. Oh yeah, this is the sphere. Cloud's radius. Yeah, cloud's radius. What if I make it bigger? Yeah, definitely rescales the the clouds. I think I'm close. But maybe the algorithm is wrong. No, I'm not sure. Clouds normal, rotate everything. Clouds UV. For a moment I think it's working, and then not really. Let's zero direction. I'm cold. But that's because I'm tired. Clouds point. Hit points. I don't think my logic is wrong. This might be one of the... Okay, so yeah. Minus light direction. Right? Project onto this sphere. But yeah, the problem is that I don't know if this actually works, if this formula works in intersecting the surface of the sphere. If you're inside. If you're on the inside. Yeah, okay. I'm starting to fall asleep. So, I'm gonna... Whoa. Okay, lots of things. So, I'm gonna go. We have... Well, cloud shadows almost. Almost. I cannot survive anymore, unfortunately. But yeah, so what we're doing here is we're creating the clouds. We have them lit. And then I'm actually trying to project hit point. Interesting. Yeah. Pateraba. Yeah. Yeah, I'm gonna think about this tomorrow and finish the clouds. And when I do, I'm going to share this shader, because why not? Okay. Yeah, I'm definitely completely dead right now. So, well, the good thing is that if I kill the clouds, if I don't add the cloud shadow, if I just do the ground, the good news is it totally works. There we go. Totally looks good. I can actually try to add the simple cloud shadows. Yeah, my brain doesn't work anymore. Well, where is my... Oh, is it this one? No, that one is actually... Okay, and this is just the shadow. Okay, whoop. Sorry about that. Again. So wait, if I show this one. Okay, so I think they're very close. Yeah, there's something going on there. Some weird thing. But yeah. Oh! Look at that. Yeah, and I can still see the clouds. But what happened to albedo? Oh, because it's only the only thing. Okay, there we go. The shadows in this case are directly below. And let's make it a little bit smaller. Let's make it a little bit smaller. Where is my cloud's radius? Yeah, let's make it 0.005. So that it falls down. There it is. Okay. Cool. Okay, let me see how that looks like. And in game, and then I'm going to slowly sign out. So, yeah. Thanks for joining again. There it is. There it is. Weird, weird clouds. It looks weird because there's blackness underneath, and it shouldn't be black. But once I actually have proper cloud shadows, then they're gonna cast onto the sphere below. Okay. So yeah. Nice clouds. Nice clouds. They really need to be like fluffy. Okay. Yeah. So that's about it for today. Next time, maybe tomorrow, I might continue, but I have a feeling like I'm just gonna fix these cloud shadows and then that's gonna be it. I'm gonna put an end to the planar shader. Okay, cool. So, see you. Here's the last sunset that you're gonna see today. Let's speed it up a bit. Okay, here we go. Here is the last sunset. Can you show high-res clouds? Oh, wait. Great stream, thanks. Thanks for the stream. Oh, so Pyrxos, you are also awake. Can you show high-res clouds? The lighting group looks amazing. I mean the clouds are a noise texture. Is that what you mean? Do you want to see the noise texture? It's sunrise soon outside. Yeah, well. Sounds bad. Okay, there it is. It's yellowish, moving on to reddish. Nice yellow color. of the sun. Oh my god, look at that. Look at that. And look at the difference. Look at the difference to this. Wait. To this. No, where is that photo? Where was the photo? This. No difference. Okay, well, now it's very red. It's very red and also disappearing. And there we go. Bye-bye light. Bye-bye light. Okay, well, I can always move the sun a bit. So yeah, let's look at that. Look at that. It's real life. Just like in real life. And if you zoom in, it looks like you're trying to touch the fusion source itself. Okay. Yeah. Anyway. Yeah. Now we don't see anything. So yeah, thanks for joining. How's the performance? I don't see any adverse performance from this. But yeah, maybe with the clouds now that I've added, I have 4 layers of I have 4 layers of sphere intersections. Because we have planet, we have atmosphere, we have planet, we have atmosphere, we have clouds, and then we have projecting from ground to the clouds, right? Calculating the intersection. So yeah, 4 intersections. Yeah, that will be fun to optimize. That will be fun to optimize. Yeah, really cool. Anyway, can you show? Yeah, noise with high resolution, but never mind. Yeah, well, I'll play with it tomorrow, and yeah. So hopefully you will see the end result tomorrow. Okay. Good night. Good night, everybody. Bye.